Okay, there we go. So hopefully this is recording this now. Okay, so we dealt with drawing graphs, and there are 3 different ways in which we went through drawing graphs, and I've listed them here. I take you can all see this, can you?
Sir.
Yep.
Yes, sir.
Okay, great.
Yes, sir.
So, the first way, the most obvious way, or the simplest way, is to set up a table of values. And you really only need 3 values for a straight line. For a parabola, for a curve, it needs to be more, but for a straight line, you just need 3. And the easiest 3 values to use are 1, 0, and -1. So go and plug those into the equation, and what do you get? -1 times 2, that's going to give me -5 over here. When x is 0, that's going to give me -3. And when x is 1, this is going to give me -1. And so there are the 3 coordinate pairs that I need to be able to plot this graph. -1, -5, that's down there. 0, -3, that's over there. -1, 1, -1, that's over there. And then all I do is go and join those with a straight line. And you guys were doing this fine with your diagrams. That was good to see. The only major criticism that I had with your drawings was a lot of you were, let's just get that line there, a lot of you are missing out on certain key things. It's useful to have the scale, or you must have the scale in your diagram. You don't have to put every single number on the axes like they have over here. You could do every second one, something like that, but just an indication of the scale for your axes is an important thing. The other thing is make sure that you put the equation of the line alongside it. Okay, so that was using a table. The second method was to use the dual intercept method, and that's where I go and make x naught or y naught. Okay, when x is 0, well, then I'm simply going to forget about that term that has the x in it, and my equation simply reads 2y equals 8, in which case y is going to equal 4. When y is equal to 0, then I forget about the term with y in it, and I'm simply going to have minus 4x equals 8, and so x must equal -2. And there we have our 2 points where the graph crosses the axis. So 0, 0, 4, 0, 4 is up over here, and -2, 0, -2, 0 is down over here. There are my 2 points. All I have to do now is to draw my line between them. And if I get the line up, there it goes. And I just pull this on. Yes, Peter, question.
Oh, I don't have a question, sir.
Oh, right. Things screened up on my screen saying you raised your hand. You must have pressed something inadvertently. No problem. And then the third method was the gradient intercept method, where we take the gradient and we take the y-cut and we use those. Now, the gradient is the number that comes in front of x. So in this case, it's going to be -2/3. And the y-cut is at the 0.01. It's that number that we get at the end there. And once we've got that, all we have to do is go to the y-cut, mark that off, and then go to my gradients. My gradient says I've got a rise of 2 and I've got a run of 3. And because the whole thing is negative, the line must be pointing up to the left-hand side. So go to the one point that I do know, go up 2 and across 3. There's my point. Up 2 and across 3. 1, 2, 3. There we go. Or I could have gone down 2 and across 3. So I've got my points set up there. I go and get my line and I simply whack it through there and extend the line out to the edge of the grid. What haven't I done so far? Well, I haven't put in the equation of this line for one thing. And I didn't put in the equation of this line over here. Always useful just to have those on there so that we can see what the actual equation is. When I've got more than one line on the graph, it's sometimes confusing. And what do you notice about the red line and the black line?
They're parallel.
They're parallel, yeah. If I went and rearranged this, I'd get 2y equals 4x plus 8. Divide 3 by 2, I'm going to get y is equal to 2x plus 4. There's my 4 of my y cut. And yeah, the gradient of those two lines are the same. So yeah, they're parallel lines. All right, everybody happy with that? Now, one thing you haven't spoken about is a set of graphs that we do need to work with that are easily overlooked, easily forgotten about, but that crop up and that sometimes cause problems. These are vertical lines and horizontal lines. Now, they have quite specific and special equations, and we don't really talk about the gradients of these lines. Firstly, because a horizontal line basically has a gradient of 0, and a vertical line, well, we can't actually define a gradient for a vertical line because, as you know, gradient is rise over run. And if I'm just rising up the line, I'm not running at all. So I'd be dividing by 0. And so gradient is actually undefined for that line. For the horizontal line, well, we need to understand that each point over here on that line has something in common. And that something in common is the fact that no matter what the x value is, the y value is always 3. So hopefully you can see that those coordinates all have a y value of 3. So this line is simply going to be written as the line where y is equal to 3. And so by the same process, the line down the bottom here is going to be the line where y is equal to -2, because every point on that line has a y value of -2. For the vertical lines, we're going to follow the same sort of logic in the sense that anything on this green line, and can I get a green colored pen? Yes, I can. Anything on this green line basically has an x coordinate that's 5 and a y coordinate that's changing. And so hopefully you can see that one way in which I can describe this line, or the way in which I describe this line, is simply to say it's the line where every x value is 5. Or for this one, it's the line where every x value is -4. And so those are equations of vertical and horizontal lines that we need to know and be prepared to use. All right, everybody happy with that?
Yes, sir.
Yes, sir.
Yep.
Yes,
Okay, great. The last thing that I want to look at is how we go about getting an equation from the line of a graph. So if I give you these 3 graphs over here, how do we go about finding their equation? Well, the way in which we go about doing that is to say, all right, any equation that I know, that I have, is going to fit this format over here. Y is equal to mx plus c. This thing over here is the gradient. And this value over here is the y cut. So if we look at this graph, what is the gradient for the red graph? Well, if I pick those 2 points there, they cross nicely through whole number coordinates. My rise is a rise of 2. My run is a run of 5. And so my gradient is going to be 2 over 5. And because the line is sloping up to the right-hand side, I'm going to say that this is a positive gradient. The y-cut, well, hopefully that's very obvious to you. It's at the point 2. So the y-cut is equal to 2. And so now, having got those two bits of information, it's really easy just to be able to write down my equation as being y is equal to 2/5 x plus 2. So I just need to get the gradient and the y-cut. If we take a look at the blue line, what is the gradient of the blue line? What is the y-cut of the blue line? Well, the y-cut's quite simple. It's going to be at the point 0 minus 1. So in other words, I know that my y-cut, that value of c, is going to equal minus 1. My gradient, again, I need to find nice points where it's crossing through whole number in coordinates. I know that's 1. I've got another one over there. I've got one down there. I've got another one over there. So I've got a whole host of these things I can look for. If I just take out these markings over here from the previous graph, what is my rise now? So my rise is that distance going up there, and that's a rise of 3. My run is a run of 1. So my gradient is going to be 3 over 1. But I've got to be aware that the line is sloping not up to the right, but up to the left, which means it's going to have a negative gradient. So all I do is go and put a minus in front of the fraction, and there I have my gradient, minus 3 over 1, which is minus 3. And so the equation then, when I come to write it out, it's simply going to be y is equal to minus 3x minus 1. And there's the equation of that line. The last one, hopefully this is all making sense to you. The last one, c is at minus 2. You can see it over there. My gradient m is a rise of 2 and a run of 6. So it's going to be 2 over 6. And it's negative, so I've got to make the whole thing negative. 2 over 6 is going to be the same as minus 1 over 3. And so my equation reads y is equal to minus 1/3 x minus 2. Everybody happy with that? Or are there some questions that you have from this?
I'm happy, sir.
Happy? Okay, if I don't get any other query or notes from people, then I'm just assuming that I can move on. But the last thing that we're going to look at is, what about if I've just got some points, arbitrary points in space, and I want to find the gradient, or I want to find the equation of the line through these 2 points here. So let's say I've got A and B. And you'll notice now that as the points stand, I don't actually know where the y-cut is, but I can find that out. Now, if you remember back, I gave you some notes in one of the videos, and I said when we're working out gradient, we're going to use this formula over here, y2 minus y1 over x2 minus x1. And in order to work that out, we know that B has the coordinates 3, 3, and A has the coordinates of minus 3, 1. And so if I want to work out the gradient of this line, I'm going to start with y2. Let's call this one x2, y2, and this one x1, y1. It doesn't matter which way around I do it. So this is going to be, the y value is going to be 3 minus the y value here, which is 1, over the x2 value, which is 3, minus the x1 value, which is minus 3. And so I'm left with 2 over 6, or in other words, 1/3. So I've got my y cut, my gradient of being 1/3. So in other words, my equation is going to look something like this. Y is equal to 1/3 x plus c. I don't know what c is at this stage. We can see from the line that we've drawn there that it's possibly somewhere around about 2. But we can do a calculation to figure that out exactly. And the way in which we can work out what c is we're going to use either that point or this point. We're going to substitute it into the equation. So I'm going to take this point over here, the point 3,3. That's my x value, that's my y value. So if I go and substitute that point into the equation is going to look like this. 3 for the y value is equal to 1/3 times 3 plus c. Now, 1/3 of 3 is just 1. So 3 is going to equal 1 plus c. I'm sure you can see that c then would work out to be the value of 2, which is what we thought was going to be anyway. Had I gone and taken the other point, had I gone and taken the point -3, 1, then I'd have had my y value is not -1. My y value is 1, is going to be 1/3 times my x value, which is -3, plus c. Now, 1/3 of -3 is -1. So I've got 1 is equal to 1 minus 1 plus c. So hopefully you can see once again, c is going to equal 2. And so I've got the equation y is equal to 1/3 x plus 2. Now, what I'm showing you here is arguably work that you could be doing in 5th form or next year. It's certainly well outside the scope of the syllabus that we work through this year, but I'm showing it to you just so that you have some extension and you can try practicing it if it makes sense to you. If it doesn't make sense to you, leave it for the time being. We can always come back to it at a later stage. Right, so on the page that's on the class page, I asked you to go and work through those exercises and then to submit it online through the due work. I see some of you have already got to that point, so well done. The rest of you, if you haven't done it yet, go ahead and do that. Are there any questions from you at this stage about what we've done here?
Sir, could you take the 2 y's and take the average and then use that as the y cut?
The 2 y's, no, not necessarily. In this situation, it would work because they are equal distance away from the y-axis. It's 3 this side and 3 that side. And so, yes, it would work in that situation because that gap is the same as that gap. However, in this situation over here, where if we went from D to C, it wouldn't work. So shall I do that as an example as well?
So I think it's all right. I got it.
You got it. Okay. So it only works if it was symmetrical on either side of the axis. So I wouldn't use that as a general rule.
Thank you.
Okay. I just need to make a quick screenshot of the participants here. Why is this not helping me? Okay. Where is the participants? Doesn't really work for me. Okay, guys, I don't have anything more to that I need to deal with you. If you don't have any other questions for me, we can call it a day, and you can get on with work that you need to do.
Thanks, sir.
All right.
Thank you, sir.
Okay.
Thanks,
Go
sir.
well.
Thanks, sir.
Thanks,
Look
sir.
after yourselves.
Sir.
Cheers.
Thank you, sir. Thank you, sir.
Cheers. Go on now. Okay, Ryan Yan with the sunglasses.